Hey, hello everyone. So, welcome to today's GFG POTD problem. So, let's see what the problem says. Move all zeros to end of array. Given an array of n positive integers, push all the zeros of the given array to the right end of the array while maintaining the order of non-zero elements. Do the mentioned change with the array in place. So, it's a pretty simple problem to understand as well. What the problem statement says is, the problem is saying to move all the zeros in the array to the right end of the array. And also, you have to maintain the order of the non-zero elements. So, for example, let's see the example. So, what they're saying is, you have to move the zeros to the end of the array and also have to maintain the order of the non-zero elements, right? So see, we have moved the zeros are at the right end and also the original order is maintained. So there are two problems to there are two approaches to solve this problem. So let's first see the knife approach, right? The knife approach can be pretty simple, like okay, and another thing, the expected time complexity is O of n and space complexity is O of 1. We don't have to take any additional extra space. Okay, so simple. What the first approach can be, take an additional array, right? And what simply we'll do is we will move the non-zero elements first. We'll move the non-zero elements into the temp array. Array of I equal to not equal to 0 and temp of, we can take another j equal to 0 as the counter array of I, right? This can be a simple approach. First, we are simply copying the non-zero elements to the temp array, right? And once it is done, what we simply can do is, while j is less than n, right? J is a counter for temp array, and simply what we can do, temp of j equal to 0 and j plus plus. So this will uh, uh, give the answer basically. It will move the zeros to the end of the array and the non-zero elements in the order, right? But the problem here is, we are taking O of an extra space. Okay, so this is naive approach. Definitely, this is not what the interviewer would expect. So let's see the second approach, that is optimized approach, right? So what we can do is, if given an array, right, 0, 0, 4, we can solve this by two pointer approach, right? What we'll do is we'll take two pointers, I and j. Okay, I and j. We'll iterate through this array through this I pointer. Okay, and what we'll do whenever we encounter any non-zero element, right? Whenever we encounter any non-zero element, we'll simply copy that non-zero element on the jth location, and we'll increment the j. J is for tracking this non-zero elements. Okay. Okay. So let's see how can we solve this problem. Let's say int j equal to 0, right? Int j equal to 0 for int I equal to 0 to n, right? What we'll simply do is, if array of I is not equal to 0, is not equal to 0, what we'll simply do is we'll copy the ith location element to jth location element, and we'll just increment the jth pointer. Okay, we'll just increment the jth pointer. So we can quickly try run this, right? So whenever I comes, okay, 3 and j I 0 j is 0, so we'll copy the ith location 3 to jth location. It will be in the same place. Then we'll move ahead. J will also be incremented as we have encountered positive non-zero element, right? So again, we found the non-zero element. We'll again copy the ith element to jth element, to ith location, the element at ith location to jth element, to jth location. So again, 5 will be same there only. Then what we'll do, we'll increment I again and j again. Okay, so array of I 0, we won't do anything. We'll move ahead. We'll move increment I. J will be there as is. And again, we encounter this. Uh, Again, we encounter 0, so we won't do anything again. We'll simply increment ith one, right? J will be there as is. Again, here we encounter non-zero element. We'll simply copy. The four element onto this jth location. So what our array will look like? 3, 5, 4, 0, 4. Okay, so this will look, yes, 4 will be here only like this. So now what we can do is simply what we can do is, once we are done, right, copying this, what we'll do, while j, where will j be? J will be here, right? Once non-zero element is copied, we increment j. While j is less than n, right, we'll simply array of j equal to 0. We'll simply copy 0 element on j and we'll increment j plus plus. So I hope you've got the problem. It's also adhering to our O time complexity and O space complexity. So finally, ultimately, yes, this 4 will be 0. Okay, so let's solve the problem quickly. Int j equal to 0 for int I equal to 0, I less than n plus plus I. Right? If array of I is not equal to 0, then array of j equal to array of I, right? And j plus plus. Okay. So yes. So once we are done, right? J plus plus. Simply what we need to do, while j is less than n, array of j equal to 0, and just increment j. So this will solve the problem. It will copy all the 0 elements remaining till n, remaining indices till n. Okay. So let's submit the problem. Let's compile, yes, and let's submit now. Okay. Yes, our solution is accepted. Thanks for watching. Kindly like the video and subscribe to my channel. Thank you very much.